Welcome to Ask and Learn.
So now we'll work on problem 10 from chapter 6. In this problem, we're told that the accompanying drawing shows a contour plot for a dyz orbital. And consider the quantum numbers that could potentially correspond to this orbital. So let's go ahead and reproduce as well as can be expected this orbital. So we have the dyz orbital. So we can go ahead and draw in a coordinate system here. We're going to have the z-axis pointing vertically. The y-axis to the right, and the x-axis to the left. So this here is the y going into the plane. This is the x going into the plane. And this is the z-axis going straight down. And the dyz orbital we'll draw in red. And it's going to lie between the y and z axes in the yz plane. So it's going to look something like this. Okay, so it's important to realize that it is not in front of the x-axis on the left and behind the x-axis on the right. The x-axis is in front on the left and behind on the right. So it's in the yz plane. So the first problem that we're asked is, what is the smallest possible value of the principal quantum number n? Now, we know that d orbitals cannot be a value of n is equal to 1 or 2. So n is equal to 3 is the lowest possible value it could have because it's a d orbital. And then in part B, we're asked what is the value of the angular momentum quantum number L. L has to be equal to 2 because that is characteristic for a d orbital. S is equal to 1, S is equal to 0. L is equal to 0 for S, L is equal to 1 for P, and L is equal to 2 for D. And part C says, what is the largest possible value of the magnetic quantum number M sub L? So when we have M sub L, the possible values are -2, -1, 0, 1, and 2. So 2 is the largest possible value. And then part D asks us, the probability density goes to 0 along which of the following planes? XY, XZ, or YZ? So we know that the YZ orbital lies in the YZ plane. So the whole orbital is in the YZ plane. So it can't be YZ. But if we can think from our image and also in our mind in 3 dimensions, we can see that if we have the XZ or the XY plane, if we were to cut that plane through the orbital, we would see that the plane would go through the nodes of the orbitals. So the probability density would be 0 in that XY and XZ plane.